Hi everyone, you're welcome back. Today I'll be talking about something very important. That is how to disinfect our water to keep it safe for drinking. Most of us take clean water for granted, but there's a lot that goes on behind the scenes to make sure that the water coming out of our tap is free from harmful microorganisms. The main thing or the main player we'll be focusing on today is chlorination. But first, I would like to talk about a few other disinfection methods out there. First, I will talk about ultraviolet disinfection. UV light is used to deactivate bacteria, viruses, and other pathogens by damaging their DNA. This method is super effective and doesn't even involve chemicals, but it has a downside. It only works if the water is clear enough. So pre-filtration is crucial. If you've not watched my previous video, that's my last video on UV sterilization, please do so you can understand the in-depth of what UV sterilization is. Then there is ozonation. So ozone is a powerful oxidizer, and when it bubbles into water, it can kill a wide range of pathogens. So ozonation is great because it leaves no chemical residue in the water, but it's also more expensive, and it also requires energy, right? Compared to other, actually intense energy compared to other methods. But since this video is all about ozonation, I won't talk much about ozonation or ozone method here. I'll probably shoot another video that will cover that and also show how ozone or ozonation or ozonator works. Another common method is thermal disinfection, which is basically you heating your water to a boil, right? It's a tried and true method, but it's not always practical, especially if you if you require a large scale a large volume of water to disinfect. Of course, I can't forget about chemical disinfection. Aside from chlorine, chemicals like chloramine, bromine, and even iodine are also used in disinfecting as disinfectant. Each has its own pros and cons. For example, chloramine, they are a bit gentler and last longer in the water than chlorine, but they might not be as effective at killing certain pathogens like chlorine. But now let's focus on the main event, chlorination. So chlorine has been the most widely used method of water disinfection for over a century. It's incredibly effective at killing bacteria, viruses, and even protozoa. Plus, it's affordable and easy to implement on a large scale. Chlorine is usually added as either as gas, liquid, or in form of sodium hypochlorite, which is basically bleach. Okay, it can be gas, liquid, or solid or granules, right? So the most important reason chlorination is so popular is that it's highly effective at killing a wide range of pathogens, including bacteria, viruses, and protozoa. Pathogens like cholera, typhoid, and dysentery were once widespread, but chlorination has played a key role in drastically reducing these waterborne diseases, especially in urban areas. So one of chlorine's biggest advantages is what we call residual protection. Unlike UV, ozonation, and some other disinfection methods, chlorine remains active in the water after it's been treated. Well, this is mostly done intentionally. So we pour more than enough chlorine in your water. Let's say your water tank. Remember, from your water tank to your building, there is mostly, if not all the time, some distance that the water would have to travel before reaching the point of use. If just enough chlorine is added to your water right in the tank, as far as the water stays in the tank and the water in the tank isn't subject to any foreign material, then it can remain safe. But you do not have any guarantee on what happens to the water after leaving the tank. That's where residual chlorine comes in. So excess chlorine is left so that the water can stay safe after leaving the tank. If the water comes in contact with any microbes on its way to the tap or faucet, such microbes would be dealt with. Even when you fetch the water with not so clean cup with some little amount of microbes, the water would remain safe. So in short, your water stays protected from any new contamination, even after traveling through a long distance. Another huge benefit is that chlorination is very affordable. It's cheaper than many other methods like ozone or UV disinfection, making it a go-to choice for municipal water treatment plants around the world. In developing country like Ghana, where budgets are tight, chlorine's low cost can make the difference between having safe water or not. If not for galamsey, Ghana water was generally safe. You see, it's generally safe, but now chlorine is also very easy to control. It can be added as gas, liquid, that's sodium hypochlorite, or solid, that's calcium hypochlorite. So you can adjust the dosage to match the water's needs, right? Which makes it highly adaptable to various water qualities and conditions, unlike UV or ozone. Well, chlorine also has its disadvantages. One of the biggest concerns with chlorination is the formation of disinfection byproducts, or DBPS. When chlorine reacts with organic matter which are naturally present in water, it can form chemicals like trihalometane and alloacetic acids. Okay, and long-term exposure to this DBPS has been linked to potential health risks such as cancer. So this is why regulatory agencies like CSIR and EPA have set strict limits on DBPS levels in drinking water. And aside from DBPS, a high level of chlorine itself can pose health risk, while small amounts are necessary for disinfection. Consuming water with too much chlorine can cause irritation in the eyes, skin, and respiratory system. For sensitive individuals, even low levels can cause problems like gastrointestinal discomfort. One of the very things I hate so much about chlorine is the taste and smell it leaves behind in water. Some people are sensitive to the smell of liquid chlorine, such as bleach, though this can be managed through the installation of carbon filter. So you smell and taste something funny, right? You see, while chlorine is also highly effective against most bacteria and viruses, it's less effective against certain protozoa, specifically Cryptoporidium, right? I don't know if I'm pronouncing that right. Okay, and Giardia. This parasite can survive standard chlorination, which is why many water systems now use combination of treatment methods such as UV alongside chlorine. There are other problems like its toxicity when inhaled and how corrosive it is to metal pipes. So to sum it all up, chlorination is tried and true method for water disinfection that's effective. Okay, it's affordable and it's also very easy to use. It offers residual protection, which keeps water safe during distribution, but it's not perfect. There are also concerns around disinfection byproduct, health risk from overexposure, and that infamous chlorine taste and that pungent smell. Chlorine also has limitations against certain pathogens and can contribute to infrastructure wear. So my next video is going to be on the comparison between chlorine and UV. Thanks for watching and see you in the next one.